The hit must be clean, Raoul, and bring many yaks, as he is a big man and you will need to drag him to the cliffs. Kind regards, Scorpio. Oh, hello. Fancy seeing you here. I'm glad you're here. I'm going to read you a story from a book that my father used to read to me, and I thought I'd just make a nice bedtime story for you. So here we go. You could use this on the kids as well if you want. Yeah. So I'm going to read to you from the Toyota Corolla Owner's Manual, 2002 to 2007. It's one of my favourites, and particularly the story I'm going to read to you tonight is Part D, the emission control system for diesel engines. And it's I mean, this edition is particularly nice. It's signed. It's a Folio Society one, but it comes with both the vacuum regulating valve settings and the torque wrench settings here in both Newton meters and in foot pounds. So the camshaft position sensor here, 9 Newton meters of torque required to fix that in. I mean, that's something I didn't know before I did this. That's the joy I feel of reading. Okay, so I'm just going to read from the crankcase ventilation system. This is part 2, the general information here. So we pick up the action. When the engine is running, a certain amount of the gases produced during the combustion escapes past the piston rings into the crankcase as blow-by gases. The crankcase ventilation system is designed to reduce the resulting hydrocarbon emissions, HC, by routing the gases and vapours from the crankcase into the inlet manifold and combustion chambers, where they are consumed during engine operation. Now, crankcase vapours pass through a hose connected from a valve cover to the air inlet duct. The oil-air separator at the valve cover separates the oil suspended in the blow-by gases and allows the oil to drain back into the crankcase. Crankcase vapours are drawn from the air-oil separator through a hose connected to the air inlet duct, where they mix with the incoming air and are burned during the normal conduction process. A blocked breather, valve or hose will result in excessive crankcase pressures, resulting in oil leaks and sludge buildup in the crankcase. Don't need to tell you how dangerous that can be. Be sure to check the basic mechanical condition of the engine before condemning the crankcase ventilation system. So, testing the electronic vacuum regulating valve is a good next step at this point. The vacuum regulating valve may be checked in situ, and first, disconnect the wiring plug. Then, connect an ohmmeter between the 2 terminals on the valve and check the resistance as given in the specifications. Using an ohmmeter, check there is no continuity between either of the terminals and the valve body. Apply 6 volts DC to the terminals, then apply vacuum to the outlet outer port and check there's no interruption of the supply voltage. Remove the EGR, the exhaust gas recirculating valve. This is described later in this section, although it does suggest that you could refer to illustration 3.12 at this point. Check the ports for heavy carbon deposits. That's always a good idea. They can cause the internal shaft to stick. Clean as necessary. Apply a vacuum of 8.3 in mercury to the diaphragm chamber. That's certainly how I like to do it. And check the internal shaft rises to open the internal inlet port. Blow through the port and check that the passage is clear to the lower outlet port. Maintain the vacuum to check the diaphragm holds the shaft open. refit the EGR valve as described later in this section. Well, as you can see, there's something there that we can all learn from, I feel. And I mean, in no way is any of that euphemistic or allegoric in any fashion at all. But I hope that'll give you something to think about, and I hope you sleep well tonight. Sleep tight.